For question 12.41, we're given the information that a 2-gram sample of a non-electrolyte, and I'm underlining it because that's an important aspect of this question, is dissolved in 55 grams of water. The solution freezes at a negative 1.23 degrees Celsius. Calculate the molar mass of this solute. Well, we know eventually we need to use our delta TF equals negative I KF times our molality. Right, where our delta TF is our change in our freezing point, I is our Van Hoff factor, KF is our freezing constant for water, which is 1.86 degrees Celsius per molal, right, and M is our molality, which is, right, how many moles of solute do I have in kilograms of solvent? So that's a little strange because we're looking for molar mass. Nothing here, right, gives us molar mass. That's not quite true. We can get molar mass from molality. I know my change in temperature. I know my Van Hoff factor. I know my freezing point constant for water. That'll allow me to find molality, and once I find molality, I can find moles, and because I know moles and the mass of the sample, I can find the molar mass of that sample. So for step 1, we want to find the molality of this solution. So my change in my freezing point is a negative 1.23 degrees Celsius. My Van Hoff factor, it's a non-electrolyte. Non-electrolyte means it goes into solution as one thing, so I have a Van Hoff factor of 1. Times my freezing point constant for water, 1.86 degrees Celsius per molal, and molality is my unknown. So I'm going to divide both sides by a negative 1.86. degrees Celsius per molal. And I see that that cancels out here, and I'm going to find the molality of this solution to be approximately 0.6 molal. Now that I know the molality, now I need to find out how many moles I have in that solution. Right, I know molality equals moles over kilogram of solvent. I have 55 grams of water, so I need to convert that into kilograms. So 55 grams of water, I know there are 1,000 grams in 1 kilogram, so I have 0.055 kilograms of water. So I have 0.66 moles per kilogram, and of that sample I have 0.055 kilograms of that solvent. Kilograms cancels out, and now I'm finally left with moles. So I have approximately 0.036 moles of this unknown solute. Now that I have moles, I can do my last calculation. Right, what's the molecular weight? Well, I know moles equals grams over my molecular weight. So I have 0.036 moles, 2 grams of that sample. So that's divided by molecular weight. So multiply both sides by molecular weight and then divide by 0.036. And I find that the molecular weight of this sample should be approximately 55 grams per mole. So I know a few of you mentioned that you didn't think you had enough information to solve this problem. We really do, because you can find the molality, and then once we find the molality, because we know the mass of the solvent, we can find the moles represented by that molality, and then ultimately find the molecular weight of this unknown. But again, a lot of that information was kind of hidden in here things like the Van Hoff factor, right? They're telling you, because it's a non-electrolyte, it goes into solution as one thing. So we've got a Van Hoff factor of 1.